Okay, so today we are covering 7.4, which is on quadratic equations, functions, zeros, and models. Okay, what I'm going to go over first is actually what are we trying to find here? Okay, when we're talking about quadratic equations and quadratic functions, let's think about what a quadratic function looks like on the graph. Okay, a quadratic function is any graph or function where the highest exponent is a 2. So it's those x squared graphs, right? X squared graphs always make the same shape. And we've seen it several times this semester already. The x squared graphs are going to be that U parabola shape. Right? They're either like this or upside down. Sometimes they're wide, sometimes they're not wide. Okay, but they all make the x squared graph. I mean the U parabola shape. Okay, what we're going to be talking about today are these 2 points and what they're called, the different terminologies for those points. Okay, these are the x-intercepts, right? This is the x-axis, the one that goes like this. X-intercepts are where your graph crosses through the x-axis. Okay, so what these are called, there's several different things. They're either called x-intercepts. Sometimes they're called solutions. And sometimes they're called zeros. Okay, that terminology is all interchangeable. What you're doing, the solutions of this model are the x-intercepts of it, or the zeros of it. Instead of solving this by graphing, which we're going to do that some on Wednesday, we're going to find the solutions algebraically by using our algebra skills, and then we'll use our graphing skills on Wednesday to do the same type of thing. The 2 methods that we are going to use to solve and find these solutions are the first method that we're going to use is by factoring. And then we have to have another method to solve quadratic equations because not all equations are factorable. And we're going to, you'll run into like a roadblock in the middle if you're using this method. So the other method is, I'm sure you've probably all heard of the quadratic formula. Okay, so those are the 2 methods that we're going to use. And then we're going to see how to do it in the calculator. All right, on number 1, it says find the zeros of the following function. But I'm finding the zeros of this function. I'm finding, if I put this in my y equals and graphed it, I'm finding where it crosses the x-axis. It's x-intercepts. But I'm going to do it by algebra. I'm going to do this one by factoring. The first thing is you want to change the y, because if you are an x-intercept, why are you still on the x-axis? Because your y coordinate would be 0. Right? Because what does the y coordinate of a point tell you to do? It tells you to go up or down. Well, if you're still on the x-axis, you haven't gone up or down. So your y is 0. So your first step in your f of whatever, this is your y, right? Just like f of x is y, so is this. So that's 0 equals w squared plus 12w plus 27. this one, and hopefully it works out. If not, then you have to do the quadratic formula, which is no fun. Okay, so if I'm using the factoring method, this has 3 terms, which makes it a trinomial. And if you're factoring a trinomial, then you're hoping that your squared term has a 1 in front of it, because that makes it a lot easier to factor. And what you're doing when you're factoring is you're saying, okay, what did they multiply together to get w squared plus 12w plus 27? What parentheses did they FOIL to get this answer? Okay, if I'm looking at that, that's why you like this squared term to have a 1 in front of it, because remember, when you're FOILing, your first step is to multiply these 2 things together. Well, if I multiply these 2 things together, I need them to equal w squared. There's only one way to do that. What do you multiply together to get w squared? W times w. Now, the last step of FOIL is this right here. This number times this number. And it has to do 2 things. It has to multiply to equal 27. So let's think of the ways that that occurs. Either 27 times 1 or 9 times 3, right? That's multiplying to get 27. You want to pick the pair that also adds to this number. So which one of these pairs adds to 12? 9 and 3. So those are your numbers that come here and here. And I actually need them to both be positive, right? Because that multiplies to positive 27. And if you add positive 9 and positive 3 together, you get positive 12, which is what you want. So those numbers come here and here. And if since your signs are the same, it doesn't even matter where you put the positive 9 and positive 3. They can be in either spot. After you do the factoring, here's your 2 factors, right? If I FOILed this, w times w is w squared. What would be your outer? 3w. What would be your inner? 9w. What's 3w plus 9w? 12w. And then what's your last? 9 times 3 is 27. So that's what factoring is. It's unfoiling it, or breaking it back apart into its factors. Once you get your 2 factors, you set them equal to 0. And solve them for w to get your 2 solutions. So here I'd have to subtract the 9 from both sides. So w equals -9. And here I'd have to subtract the 3 from both sides. So w also equals -3. So -9 and -3 are your solutions, right? So if I put this in, if I put x squared plus 12x plus 27 in my y equals and graphed it, the parabola would look like this. It would cross through the x-axis at -3 and -9. Okay, I'm just tying it together to what this means, what you're finding when you find that -3 and -9. Okay, now I'm actually going to kind of jump around on this. I'm going to cover all 6 of them, but I'm going to do them out of order because I feel like they are out of order. I'm going to skip 2 and go to 3. Because on this one we got lucky, because the factoring of it wasn't too bad. So what about on number 3? We've got x squared plus 5x minus 3 equals 0. Okay, don't write this down. So if I try to do it like I did the last one and factor it, I could get the x squared, right? That's no big deal. X and x to give me x squared. But now remember, these two numbers have to do what two things? They have to multiply to equal -3. So let's see how I would do that. 3 times -1 or -3 times +1, right? That's how you multiply to get -3. But what do those numbers also have to do? Add to 5. Which one of those pairs does that? Neither one of them. So factoring, that's why we have the quadratic formula. Is because you just can't, it's not factorable. You can't solve it by factoring. So here's my quadratic formula. And here's my spiel on memorizing the quadratic formula. There's absolutely zero reason for it, right? Memorizing a formula does absolutely nothing for you. Now, if you haven't, you might have memorized it already in high school or whatever, but if you haven't, if you do the formula enough, you just naturally memorize it, okay? But you can always look up a formula. What's more difficult is knowing when and how to use it. Knowing that you're supposed to use this solving quadratic equations, especially if they don't factor. And then knowing how to use it. Okay? So again, just because I run into this all the time with my kids, if they can put it on a flashcard and flip it over and memorize it, they are going to ace a test. If they have to explain anything, or if you ask it to them in a different way than what that flashcard says, they're like, that's not on my flashcard, right? Memorizing this does not mean you know anything, okay? So there's no reason to spend a lot of time trying to memorize that. That's my spiel on that. I won't talk about that anymore. Okay. So first of all, just like when you're factoring, you want to set the equation equal to 0. And you also want to make sure your terms are in the right order. These are all set up for us to where they are. Okay. Then you're going to say, okay, what's all this A, B, and C mess? Your A is always the number in front of your X squared. Your B is the number in front of X. Your C is your constant, which is the number without the letter hooked onto it. Okay, so I like to actually write it out. My A is in front of X squared. If you don't see it, it's an understood what? It's a 1, right? That's 1x squared. My B is 5. And my C, don't forget your sign, is -3. Now that I know my A, B, and C, let's plug those in to my formula wherever A, B, and C are. So let's see, I'm going to have X equals. I like to call this, instead of negative B, I just like to call that the opposite of B. Because I feel like if you say negative B and then you come over here and you're like, okay, this is positive, I'll put it in as negative, or do I put it in as, so it kind of is confusing. But I feel like if you say, what's the opposite of B? What's the opposite of +5? -5. Then you've got the plus and minus. That's what's actually separating your two different solutions. That's what's giving you the two answers, is that plus and minus. Then you have this long square root. Underneath the square root, the first thing is you're going to have your B number, but you're going to square it. And squaring it doesn't mean to multiply it times 2, right? It means to multiply it times itself. So my B is 5. If I square it, I get 25. Then after that, the very next thing is always the same in every single problem. It's a -4. And then your A and your C, and you're just coming back to what you've written. 1 is A, C is -3. So there's your numerator. It's a little complicated. Your denominator is 2 times A, which in this case is just 2 times 1. Now, every step of solving quadratic formulas from here on out is just simplifying this fraction. The first step in simplifying it is seeing what is underneath the square root. So I'm going to keep it a square root. I'm just going to write this as one number instead of 25 minus 4 times 1 times negative 3. You could actually put that all in your calculator at once, just like it's stated right here. So just plain 25 minus 4, exactly how it's written. Open parentheses, 1, close, open parentheses, negative 3, close. So again, exactly like it's written, and then hit enter to see what really is underneath that square root. When you type all that in and push enter, you just get 37. So all of this is just 37 over 2 times 1 is 2. This particular problem, number 3, asks for your answer in 2 different ways. It asks for the exact solutions, which is what this is. And there's actually 2 answers here. One of them is negative 5 plus the square root of 37 over 2. The other answer is negative 5 minus the square root of 37 over 2. When you're typing this into MATLAB, here's what I would do. I would go, down in your tools. You have this tool right here that makes you be able to type in a fraction. They also down here, so you don't have to type it all in twice, down here in your toolbox, you'll see this button also. So you can type in you can hit this button and that'll do plus minus right there. That way you don't have to type in it as 2 separate answers with a comma in between. So that is in your toolbox. Now so those are your exact solutions. After you enter your exact solution, it's going to say, what are the approximate solutions to 3 decimal places? So you're going to have to type this in your calculator as 2 separate answers, because you're type it in first. And when you put it in your calculator, to not mess up, you need to put the numerator in parentheses, because that's just going to keep all of that as a numerator and then separate from the denominator. So just like this, you'll type in open parentheses, negative 5. Now, you can't do plus minus at the same time, so you just do plus to get your first one. Now, your square root, do you see the x squared button? Right above it is your square root. So you just need to hit the second and then this x squared button to get your square root. Put your 37 under there. Now, after you put the 37, do you see how your square root is not going to stop going until you tell your calculator, okay, I'm done typing in what's underneath the square root symbol. You do that by hitting your right arrow. Once I hit the right arrow, that says, okay, I'm done typing the square root. So then you put your closed parenthesis, and then you just hit divided by 2. And then hit enter. It says to round it. See why it's approximate? Because it's a decimal that goes on to the end of the calculator. It really goes on beyond that. So the approximate is because we're going to round this to 3 decimal places. So let's see, behind the decimal point, we're going to go 3 spots. So 1, 2, 3. So 0.541. But remember, you need to see whether or not that 1 rounds up to a 2 by looking at the number after the 1, which is a 3. 5 or above rounds that to 0.542, right? If it's below a 5, then it just stays 0.541. So that's one approximate solution. We've done the one with the plus. Now I'm going to type in, yeah. That should give you a second. Oh, it's not giving you the decimal. No. Try to do with the minus one. So now I need to do open parentheses, -5 minus the square root of 37. Now remember, right arrow and then close your parentheses, divided by 2. And again, you're going 3 places behind the decimal. So this one gives me -5.541 as your other approximate solution. So these are exact. And those are approximate. Okay, so we've done 1, 3. We're actually going to skip 4. We're going to do 5 and 6 and then come back to those others. Skip 4. Going to 5. We've got 3x squared minus 7x minus 5 equals 0. So it's set equal to 0. All my terms are in the right order. By the right order, I mean that the exponents are in descending order. You start off with your squared and go down from there. Okay, so I can go ahead and choose my A, B, and C, which will be 3, -7, and -5. And plug it in. So your x's are going to equal the opposite of B. Here's my B is -7. So what's the opposite of that one? Right, +7. Plus or minus the square root. Now, the first thing you have under your radical is your B, but you're going to square it, which means this number right here is not ever going to be a negative number. Because even if your B is negative, what happens to it when you square it? It's going to turn it positive, isn't it? Because what happens if you get -7 times -7? Right, +49. If you square a negative number in your calculator, make sure you put parentheses around it. If you don't, if you just type in -7 and hit the squared button, it's going to tell you -49. Then the -4 that comes from the formula. And then your A and C, which is 3 and -5. And you put that all over. Your denominator is 2 times your A, which is 3. That in your calculator to see what's underneath that square root. So you've got 7 plus or minus the square root. When you type in 49 minus 4 times 3 times -5, what does it give you? 109. And then your denominator is always a lot easier to figure out. 2 times 3, which gives me 6. So there's your exacts. Let's see if I type in. Remember to put parentheses around your numerator. So open 7 plus square root 109. Hit your right arrow to get out of your square root. Close it. divided by 6. Okay, this time, did I have to round up after when I went to my third decimal? I got 2.9067. So 906 is 3 places behind the decimal. But when I go behind that 6, I see a 7, which means I need to round 906 up to 907, right? Again, this is why it's approximate, right? It's not really 2.907. It's approximately that. Then type in the same thing, but this time give this one the minus. So parentheses around my numerator. 7 minus second square root 109 over 6. Enter. Again, 3 places after the decimal. There's 0.5733. So I'm not rounding up this time. Right, number 6. F of x equals 3x squared minus 5x minus 11. All right, my A, B, and C are 3, negative 5, negative 11. Plug it in. The opposite of B. So here's my B, which means the opposite of it is positive 5. And then my B squared would be positive 25. And the negative 4, because that's what's always there. A and C will be 3 and negative 11. All over 2 times A, 2 times 3 again. I'm just going to put what's underneath the radical in my calculator, which is going to give me 5 plus or minus the square root. When you put all that in your calculator, you get 157 over 2 times 3 is 6. And this one just asks for the exact ones. You don't have to do the decimals. Okay, then we're going to go back to number 4. Number 2 last. Now, number 4 is going to have something in it that we haven't talked about. It's actually taught more in the class before college algebra, transitional algebra, or foundations of algebra. And it's talking about, so in other words, it's just assuming that you know it when you get this. An I, which comes from the square root of -1. The square root of -1 is equal to I. It's an imaginary number. It's not actually on the number line, right? If you have a number line, you're not going to be able to go to it and say, there's 3i, like you would be able to go to it and say, there's 3. And it comes from the square root of -1. So if you have in the process, when you're doing these problems, if you ever run into when you simplify what's underneath your radical, and you get, like on the last one, we got 157 under here, which was fine. But if you get a negative number, under there. It's not going to want you to write that in the answer. You don't ever want to leave a negative in your square root. So how you're going to fix it is you're actually going to pull out the square root of -1. Or in other words, turn it into this. We're not going to actually go through all these steps. We're just going to jump to the end of it. But this is what's happening here. I can break this square root up to anything I want as long as these two numbers multiply to what's under the original. The square root of -1 is just equal to I. So in other words, if you end up with a negative under your radical, just pull the I out of it and put it in front of it. And that turns what's underneath your radical positive. So in other words, on this next one, we're going to be in the process of solving it. And once we get simplified underneath our square root, it's going to be a negative number. So before we enter our answer, we're going to pull the I out of it. On number 4, this is where we see it. F of x equals 5x squared minus x plus 9. Minus x plus 9 minus x plus. So everything works the same because we don't even know we're going to end up with an I yet, right? We just see the problem. So my A, B, and C are 5. My B is -1. And my C is +9. Plugging into my formula, I need the opposite of B. So the opposite of this B will be +1. And the plus and minus, and then your long radical. The first thing under your radical is your B, but square it. If you square -1, what does it turn into? +1, right? Then the -4 from the formula. And then A and C, which is 5 and 9. All over 2 times A, which is 2 times 5. When you type all this into your calculator, what does it give you? -179. Over 2 times 5 is 10. So like we were talking about, if this ends up being a negative, to fix that negative means to pull out its I. And you just put it right here in front of the radical. So you're going to have 1 plus or minus I square root of 179 over 10. Okay, there's an I down in your toolbox when you're typing in this answer, but then you can also use the I on the keyboard. It'll accept either one. All right, last one. So going back up to number 2. So I know I've been all over the place, but there was reason for that. We needed to get warmed up for number 2. Number 2 just has more steps at the end. F of x equals x squared minus 2x minus 4. Starts off the same. A, B, and C. Okay, you would try. That's the same thing every time I do this one because it looks like it should be able to factor easily. Okay, but what happens? You would start off x and x. How do you multiply to get -4? both ways. But if you're trying to pick the pair that adds to -2, that's where you run into a stumbling block, because none of these pairs do that. Okay, so that definitely that's what you would try first, because factoring is a lot easier than the quadratic formula. And this actually is going to take it as far as you can go with the quadratic formula. My A is 1, my B is -2, and my C is -4. Now let's see, the opposite of B will be +2. Then your plus and minus. And then your long radical. Under the radical, I'll have my B, but I'm going to multiply it times itself. So it'll give me +4. And a -4 from the formula, A and C, which is 1 and -4. All over 2 times A, which is 2 times 1. So nothing out of the ordinary yet. So let's see what's underneath here. So I've got 2 plus or minus the square root. 4 minus 4 times 1 times -4 gives you +20 over 2. Here's what's different. On the other ones, what was underneath this radical couldn't be simplified. The numbers 157, 109, 37, 179, all those numbers cannot be simplified as a radical. And what I mean is they don't have any factors, which means numbers that are multiplied to get them, or numbers that go into them, that are perfect squares. What a perfect square is a number, when you take the square root of it, you get a whole number instead of a decimal. Numbers like this. Right? The list can go on and on. Those are all perfect squares because, for instance, 36, if you took the square root of it, what would you get? What times itself is 36? 6. The square root of 49 is 7. Square root of 9 is 3. These are all perfect squares. Okay, so is 1, but we don't use it in this, the reason that we're using this. If your number that is here has a factor, which means a number that goes into it that's a perfect square, that means you need to simplify this. So let's think of the numbers that go into 20. 20 times 1, 10 times 2, 5 times 4. And like I said, we don't use 1 for this purpose. If I take the square root of 10, it's going to give me a long decimal. If I take the square root and punch the square root of 2 into my calculator, it's going to give me a decimal. If I put the square root of 5 in my calculator, it's going to give me a decimal. What is it going to tell you if you put the square root of 4 in your calculator? It's going to tell you 2, which means this is not simplified because there's square root in it. There is some perfect squareness inside of it. So here's how you fix that. You're going to break this apart into 2 square roots. The 2 square roots have to multiply to 20. So we've already got all those ways listed. So let me show you what that looks like. So all I'm doing on this next step is breaking apart the square root of 20 into 2 square roots that have to equal 20 when you multiply them. And this number right here, the one that goes in the first one, has to be the number that you found out was the perfect square. So the 4 has to come here. 4 times what is 20? So the 5 goes there. So now that you have pulled out the perfect square part of 20, now you can even take it further because what did y'all say? What is this really? It's just 2. So now I've got 2 plus or minus. I'm turning this into a plain old 2 square root of 5 over 2, which means now this fraction actually reduces just like any other fraction, because these 3 numbers all divide by a common number. What goes into 2? 2 does. So you divide just like you do. You're going to turn them all into what? When you divide them all by 2, what are they all going to turn into? They're all going to turn into 1, right? Because what is 2 over 2 anyway? It's 1. 2 over 2 here is 1. So that they just all turn into 1s. So let's see. In front of the plus minus, you've got a 1. Then you've got the plus minus. Then here you've got 1 square root of 5. I don't even need to write that 1, right? 1 square root of 5 is just the square root of 5. And what about this one that is your denominator? Do you need to put a fraction if 1 is your denominator? No. So this right here is your answer. And it doesn't ask for approximate solutions, thank goodness. Now, after we went through all this, I'm going to ask y'all, if you are an online student, you can come to campus. I'll send this to you in an email to get this program. If not, you're going to have to do everything like we did it all the way today. I have a program in my calculator because from now on, I'm just going to want to be able to get to this fast without going through all of this. So I have a program on my calculator and I can sync our calculators together. Maybe not that one. I have to get a mini USB to mini USB, I think, for that, but I can get one. If class time is not a convenient time, I'm saying this mainly for my online students because I use this video for them. You can come to campus in the Learning Assistance Center that's on the 3rd floor of the Campus Center building, and they will put this quad program on there. Here's what happens when you have the quad program. It's under PRGM, and I'm going to give you all this program in just a minute. It's actually going to give you a lot of programs. If you scroll down to quad and hit enter twice, it's going to say, okay, what's your A? What's my A on this problem? 1. So I would hit 1 and then enter. Then it's going to say, what's your B? My B is -2, enter. And then it's going to say, what's your C? Mine is -4. The first thing it's going to give you is the decimal solutions, the approximate solutions. When it asks you for approximate, this is what you use. You hit enter again and look what it has. 1 plus the square root of 5, 1 minus the square root of 5. So it's going to do quad problems for you. So throughout the rest of the semester, anytime I have to find an X-intercepts of a parabola or something, I'm just going to use my quad. Okay, we're going to get there faster because we're going to need to use this solution for something else. Okay. All right, so for those of you at home, you can either make an appointment to come up here to meet me to get this program or go to Learning Assistance Center, 3rd floor of the Campus Center building.